Hello and welcome. Today we are going to solve our third problem of Leetcode, that is longest substring without repeating character. So let's first explain this problem, then we are going to solve this. Okay. So we have to return the length of longest substring that does not have any repeating character. Okay. So I don't think that we need to explain this question anymore. So we all know what we have to do. We have to find out all the substring and we have to return the length of the longest substring that is going to be equal. That is going to be the maximum of length. Okay. So first we'll find out that what type of problem this is, how we can solve this, what is the approach that we are going to apply. So let me tell you that this problem belongs to sliding window or two pointer problem. Okay, so how we can find out by ourselves that this problem belongs to sliding window or any of the problem. Let's say we have come with one another problem that belong to sliding window, but you don't know how to find out that this problem is belong to sliding window. So how we can ensure by yourself that any of the problem belong to sliding window. Okay, so for that we have to analyze the test case and we'll build a pattern, and using that we'll find out that this problem belong to sliding window. Using that you will be able to decide yourself that this problem belong to sliding window. Okay, so let's write the first test case, that is s equal to a b c a b c and b b, and output for this result, this string is 3. Okay, we can check that there is a substring of length 3 that does not have any repeating character. Again, there is a substring of length 3 that does not have any repeating character. Again, there is a substring of length 3 that does not have any repeating character. Same, there is a substring of length 3 that does not have any repeating character. We'll move forward and we'll check that there is a substring of length 2 that does not have any repeating character, and there is a substring of length 1 that does not have any repeating character. So that what is the maximum length that we got of all the among all the substring? The length of 3. All of these are of length 3, but we have to consider only one of these because the length of all these are same, so we can consider any of these. Okay, so our result is going to be equal to 3. Okay, whenever we have to take care of our current index as well as our previous index, and we have to move forward or backward the indexes, we can say that this problem belongs to sliding window. Okay, so how we can ensure that we are taking care of both the indexes, the current one and the previous one? So let's again see this a b c a b c b b. So let's say our current index is here. Let's take two indexes, that is I and j. We can say this right or left also. This one is right and this is the left one. Let's consider this right one left. Okay, so at starting indexes of both are equal to 0. Okay, so we are at index 0 and we'll check is there any repeating character. No, we'll move our right index here. J is here, I is here. We'll again check is there any repeating character. No, we'll again move our right index here, J. Our I is at A. We'll again check is there any repeating character. No, so our current length is 3. Okay, again we'll move forward and check whether we have any repeating character. We can see we have a repeating character at our left index, that is I. A is a repeating character, so we'll move our I from I to here. Okay, and our J is at here. So again our result is 3. Same will go for up to here, and our I will be at here and J will be at here. Okay, so again we'll move forward and see that is there any repeating character. Yes, we have a repeating character at this index. Okay, so we'll move our I from here to here and J here. Okay, so again length of this is 2, which is lesser than our current result, so we don't have to update this and move forward. So our main goal was to consider that how we are moving the indexes. Okay, so we have seen that we are moving our indexes based on condition that we are finding any repeating character. So in such type of problem we have to use the sliding window pattern. Okay, so we have ensured that we are going to use the sliding window. But how we can use sliding window? There can be multiple way to implement this. The first approach, that is going to be brute force, is using two for loop. So we will start iterating from I equal to 0 to n, and inside this for loop we will again iterate for j equal to I plus 1 to n. Okay, and we will consider all the substring among I to j. Okay, and we have to check whether this substring contains any repeating character or not. If it is not containing any repeating character and the length of this substring is higher than our current result, we have to update this. So there is some work that we have to do here. We can also do one more thing, like we can create a function for this, and we can pass this all task into one function. Okay, but that is another case that we are not going to implement here, because our goal is to implement in optimized way. Okay, so again we can see that there is a n time of this loop, n time of this loop, and again n time of this. So test for this approach, our runtime complexity will be going to equal to n cube. Obviously this is not the optimized one, and we don't have to use this one. If we'll use this, obviously we are going to get a TLE, that is time limit exceeded. So again, so how we can solve this? We can solve this using same approach but in an optimized way. So again, let's write down the test case as equal to a b c, a b c, b b. Okay, so we have used the hash map in our one of our previous video. Why we will going to use the hash map? Because we have to take care of the our previous indexes also, and apart from indexes we have to also look for our previous characters. So when we have to take care of more than one elements, like key in a key value pair, like we have to take care of character and that index also. So we have to store this character with their indexes. So again we have to store these two things in packed form, like we have to store this in character and index in key value pair. So whenever we have to store any of data in such way, we are going to use what data structure? Hash map. Okay, so we are going to use hash map. Is that clear? I think it should be. Okay, so first write down the pseudocode for this, and again we'll understand that pseudocode, and then after we are going to code this. Okay, so we are going to need a hash map of character and integer type, and there is a left index equal to 0 and a right index. We'll start iterating from right equal to 0 to right lesser than n, and we will move forward this right indexes. Okay, and we have to do some work in between this. Okay, so if whenever we found that there is a repeating character, how we can find that we will look in our map, that is there any index that is already present in our hash map. That is, so how we can check that? We will use map dot contains key or current character. Let's say it is cur equal to s dot caret right. Okay, yeah. So whenever you will found that our current character is already present in hash map, what we have to do? We have to update our left index. How we can update this? Left will going to be equal to maximum among the left, that is already, and our and the index of our current index. Map dot index of our current character, map dot get cur plus 1. Okay, so let's say we are here and left is here, right is here. So what we have to do, we have to update the left with this index, that is 1. Okay, so how we can get this? We'll find out the index of this left, this character, that is a, that is going to be equal to 0, and we'll again add 1 to that character. Okay, so this is going to be equal to 1. Okay, that is what we are doing here. So left has been updated, right? Now we have to put correct character with current index, that is right. Okay, and at last we have to update the result, that is going to equal to result max among result and right minus left plus 1. So let's say left is this and right is this. So length of the substring is right minus left, that is 2, plus 1, that is going to equal to 3. Okay, so that is what we are doing here. We are updating our result with maximum possible length. Okay, so this is the pseudocode. Okay, now again let's do a dry run for this problem and understand this. Okay, so s equal to abc abc ab, there is a hash map. Let's say I and j, we are not using left and right, or L or R you can use. L R, at starting it is 0, so at we are at 0th index, 0 1 2 3 4 5 6 7. So at starting we are at 0 index. Okay, I and j, we will put this in our hash map. A 0, we will move forward, j will be at here, sorry, R will be at here. Again we will check whether we have B already present in hash map. No, we can put this in hash map B1. Same for C2, and during this we will also update our result. So till now our result is going to be equal to right minus left, that is 2 minus 0 plus 1, that is 3. Okay, now again move, we are at index 3. We'll check whether this character is already present in the hash map. Yeah, we can see that A is already present in hash map. So again we have to update this with what index? L will be updated with length with index of this A plus 1, that is going to be L is equal to 0 to 1, this will be 1. Okay, and our L will be here, and again we have to update the index of A. What is the index of A current index? That is 3, so we'll update this with 3. Okay, so again the result is going to be equal to 3 minus 1 plus 1, that is 3. Okay, same will be taken care till index 5, and our I will be at index 3 and R will be at index 5. Whenever we will going to move at index 6, so this is going to be equal to 6. We have skipped few part in between because we don't wanted to repeat this and make this video more larger, that's why. Okay, so we are at index 6 and our left index is at 3. So we'll check out that whether we have B already present in hash map. Yeah, so the last index of B will be here at 4 and C will be at 5. Okay, so we can see that B is already present at index 4, so we have to update our left with index of B plus 1, that is 5. So left will be here, left will be 5 and right is 6. So length of 6 minus 5 plus 1 is 2. Obviously this is lesser than the current result, so we will not update this. Same will be followed for index 7. So we will update this b to 6. Is b already present in hash map? Yes, b is already present. So we have to update this with length 7, and the current index of I will be again going to be equal to 7. So 7 minus 7 equal to 0 plus 1 1. So we don't have to consider this one. Our result is 3. Okay, I think now it's clear. Let's go and write the code for the same. Yeah, so first we will going to need a hash map of character and integer type. Let's say this is named as map. Again we will going to need a result at starting. It is going to be equal to 0 and left equal to 0. We have to iterate from right equal to 0 to right will be lesser than n. Again we have to find out this n here. N equal to s dot length and right plus plus. There will be some condition that we have to check here, and what we have to return at last? Result. What is the condition that we have to check here? That whether our map is already containing this current index, current character. So what is the current character? It is char ch equal to s dot char at right. Okay, so if map dot contains key ch, if map is already containing this character, then we have to update our left index. Okay, so in that case left is going to equal to math dot max left map dot get ch plus 1. Okay, now we have to put our current character with its index into the map. So map dot put ch right and update the result equal to method dot max result and right minus left plus 1. Okay, so we have solved this. Let's run this. I don't think that there should be any error. Let's test all the test cases, the 3 that we have given already. Yeah, all of 3 test cases has been satisfied. So let's submit this. Yeah, we have passed all the test cases and our solution has been accepted, and this one is the optimized one. Yeah, we can also optimize this further if we are going to use a integer array of length 26, that we know that we are going to use only 26 characters, so we can use that integer array, and that is going to work same as hash map. Okay, so thank you. If you like this video, please make sure to like this and subscribe the channel. Thank you.